Okay. So how many people here want to learn about SQL? How many people are just in this theater because they're playing the movie afterwards? Okay. So let's get started. We're going to talk about how to think in SQL. Got me? There we go. So these are a couple slides I got off of dbareactions.com. It's a site that DBAs use to make fun of developers. Yeah, sometimes I generally do that to a lot of code. Yeah, if you replace a cursor with a while loop, something wrong. And store procedures are as vulnerable to SQL injection as everything else, okay? So let's not go there. So talking about how to think in the SQL-based mindset, we're going to talk about optimizing, organizing, indexing, prioritizing, maybe a little innovation. I'm Kevin Devine. I was a former database administrator. I'm a current software engineer at MRI Software. That's my Twitter and my Yahoo account. Anybody want to criticize me for having a Yahoo Mail account? I got it the day it went live. So I'm old. Okay, so this is generally how developers see databases. Developers see databases as, I need to find a pebble on this beach. How do I do that? Now, a well-designed database looks like this. It's nice and structured, and you can find exactly what you're looking for when you want to find it. And that's what we want to talk about, is how to get to where you're thinking of a database as nice and structured, not looking at it as how do I find a pebble on a beach. I took this quote from Itzik Ben-Gunn. Itzik Ben-Gunn's been a SQL MVP since 1999, written I don't know how many books, quite a few. And he talks about the path a SQL developer takes. And you start off with your procedural. You're using cursors and loops and functions and temporary tables to do everything you would normally do in your C# or your Java code. And you don't even realize how bad it is. Because it probably runs perfectly fine in your development environment. I'm working on 1,000 records. It works fine. Everything's running fast. Then you put it on production and you go, well, I don't know why it's slow. It must be the hardware, because developers love to blame the hardware. So the next step in the development is kind of realizing maybe it is the code. Maybe there's something in the code I can improve. But I don't know how to do that. So you kind of look to some experts out there. Maybe an Itzik Ben-Gunn, maybe a Brent Ozar, maybe a Paul Randall, one of those guys. You follow them online. You're like, these guys know what they're talking about. I'll follow what they say. And then you get to the maturity level when you're talking SQL development. And this is when you not only know what you're supposed to use in SQL to be optimal code, but it's second nature. You're like, I know I need to iterate over this. I can use a select over, partition by, not I'm going to use a cursor. So we're going to talk about a few things here. First is when you are programming in a procedural language, in a lot of cases you're telling the computer, how do you do this? In SQL, the question is not how to do it. It's this is what I want. Or this is what I want. The next one is that looping is not something that SQL likes to do when you tell it to. It's perfectly fine doing looping on its own in the SQL optimizer. It does not like it when you tell it to do that. We're going to go over some SQL terminology, and then we're going to talk about results-oriented thinking. So first, we're going to talk about this what do you want versus how do I get. And in this case, if you're doing something where I say find all customers that are in the state of Ohio, let's say I gave you a flat file that just had lines that had addresses on it. How would you find what was Ohio? There's a couple ways. Maybe a regular expression. Maybe you'd iterate through each line with an index of. Maybe you'd shove it into a data table object and use link. A couple different ways you could do that. In SQL, if it's in a database, you just go select star from customers where state equals Ohio. You're not worried about how it's giving you that data back. Just, that's what I want. And so that's what SQL kind of expects. Now I want to talk a little bit about looping. There's a term that DBAs love to throw around called rebar, and it stands for row by agonizing row. When I want to get back data, I want to get it back in a chunk, or I want to process things in a big set, not each row. And there's a lot of ways that incorrect coding will get you row by row. And we're going to show a few of those. I say cursors or curses up there. That's actually somebody's quote that I took. I'm not exactly sure who I first heard it from. There are some cases where you need to use a cursor. In general, though, cursor's a code smell in SQL. Look at it, make sure it's good. While loops are hardly ever better than a cursor. I've seen people that go, I heard cursors are bad, I changed them all to while loops, and that's why I put up that slide at the beginning. While loops are actually worse than cursors. Don't use while loops. I don't even know why the command exists in SQL. It's bad. I think there's some edge cases, I guess. Then we're going to talk a little bit about how functions calls non-Sarge. Sarge is search arguments. I'll get back to this in a minute. First thing I want to talk about is my first example was a trigger, not that trigger. It was in a trigger. This is the trigger. Don't read this. That'll take too long. But this was the trigger. I kind of modified it so it's in InventureWorks. This isn't actually the production code because they wouldn't let me show that. And what this was designed to do was if I have a special offer, I want to put a special offer into my database, and there were multiple ways that it could get into the database, either through the UI, through a web service, and there was one other way it could get in. So they decided the best way to make sure that there was data integrity was to put a trigger on it. And what this trigger was designed to do was to make sure that the dates don't overlap on the special offers. And here's the cursor. And what it cursored over was what was inserted. The inserted is in SQL in a trigger. Inserted is what you are sending in. And in testing, this actually performed perfectly well when they were going through the UI. The UI restricted them to putting in one entry at a time. Well, it only has to loop once. The problem was when we did performance testing on this and we were inserting 25,000, it took a little longer. And then it goes up against the special offer table and checks it. And I looked at this statement and I said, wait a second. All this is doing is looking at what the cursor's looking at, putting it into a couple variables, and then comparing them. And I thought, if you just compare what's in the inserted table directly, as opposed to each individual one, you're still going to get the error, because this was an all or nothing trigger. It either inserted all 10,000 or it inserted none of them and gave you back an error message. It didn't insert a few of them and then the error ones didn't get inserted. So I took this out. This is actually the completely rewritten trigger. That's the whole thing. And I just rewrote it to that. In fact, I even put the error message right into the select statement. Now, that is a little bit more complex looking for a single statement, but it does the exact same thing, and it kicks out the errors. And the performance gain wasn't so much in seconds. The previous trigger with the 25,000 record insert took 2.5 seconds to run. Well, that's not too bad. This one takes milliseconds, but 2.5 seconds maybe was acceptable. The problem was that it did 3.5 million logical reads and spiked the CPU to 100% for those 2.5 seconds. This one doesn't. This one, the CPU hardly went up. I think it was 300 logical reads or something like that for that insert. And again, spiking the CPU for 2.5 seconds, maybe not bad, but it depends on how many clients are connecting to that database at that particular 2.5 seconds. You can start to back things up quite a bit. So you can see the before and after here. So it's a lot shorter code, I guess. It's just got a more complicated statement, but it ran much better. So I was talking about cursors. The biggest problem I have seen with cursors is that people just declare them. A cursor's a loop, allows you to loop, is that people define them with the defaults. And most people don't even realize this, that with a cursor, you have your data set, you have your select from your cursor. If I go back to the cursor here, you can see it does a select on description, discount, and so on and so forth. And you can actually see that this cursor here is declared a default. And one of the things as a default cursor is that I can delete from the inserted table inside the cursor. And the next time it iterates, it'll pick up those changes when it's defined by default. Also, in a cursor, you generally see a fetch next. You can also fetch previous in a default cursor. However, if you're not doing either of those two things, which most cursors don't, most are just looping forward, and they don't care whether or not the cursor is updated, static fast forward, static makes a copy of the data you're using in memory, and it will run through that. If you update the table you're cursoring through, it doesn't care. It's not going to pick up that change. Forward only means you can't fetch previous. There's also another keyword called fast forward. Fast forward does allow updating, but it also goes forward. Sometimes fast forward is a few milliseconds faster than static fast forward. Depends on the situation. Can't really tell you what that situation is because I've seen it go either way. So in this case, that's the it depends kind of thing of go one way or the other. Just try it both ways. But if you're going to use a cursor, please don't have it as the default. Even define that it's updatable or something like that. Don't leave cursors naked. Okay, so what have I got here? I have I don't have, wait a second. Which demo would I say was here? I got the wrong thing? Oh, okay. Never mind that. Back to the slideshow. Okay, great. It started over because I don't know what button I'm supposed to press. Okay. That's in the wrong spot. Okay, going on to Sarge ability. Sarge stands for search arguments, and again, DBAs throw out the word Sarge because they like their acronyms as much as everybody else. And one of the things about functions being in the where clause, especially, sometimes in the order by clause, they cause it so it doesn't know what index to use. And you want it to pick the best plan, and one of the easiest ways to fix poor performance is to see whether or not it's using indexes properly. So this statement comes right out of AdventureWorks database, which is the demo database if people don't know. And what it's trying to do is determine, it wants to get either the ship date or order date that's between June 24th, 2001 and June 25th, 2001. Actually a very finite data set. However, the problem is that function, cast, convert, is null, all of that causes it not to know how to use an index properly. So you change it to something like this. It does the exact same thing. Ship date between the two dates, or the ship date is null, and the order date is between those two times. So in this case, I actually have the demo for this one. If I were to run this, and I don't know if you can see, it's probably big enough, set statistics IO and time on. So when I run this, reduces the same data sets, and in all honesty, the time is not that different between the two, but what I want to direct your attention to is the fact that this one does 104 logical reads, and this one does 4. It's not a huge difference on this data set, but if I perhaps had more than, I think this has 32,000 orders in it, if this had 3.5 million or 25 million or 100 million, that number on the top is going to get a lot higher. The number on the bottom is not going to get that much higher. So, and also you can see the execution time. The second one actually executed in 0 milliseconds, and the first one was 276. So again, not, it didn't take a ton of time, but again, the top one took CPU time, the bottom one didn't. So, okay, back to the slides. So, let's talk about some SQL terminology. I've been throwing out indexes. When you're talking about an index, you'll see these are the general index terminologies. Now I'm using SQL Server, Microsoft SQL Server terminology here. I do have a quick slide on MySQL because the terminology is similar. You're going to see some of the same stuff. They just have different words for it. All this stuff still exists in MySQL, Oracle, Postgres, not any of the NoSQLs. That's why they're called NoSQL. So clustered index seek, clustered index scan, index scan, all this stuff. So let's talk about clustered index seek and scan. A clustered index scan means that it went on the clustered index. The clustered index is a single index on a table, and it's how the table is stored on the disk. It is the exact order that it is put on the disk. Matters more if you're using magnetic disk versus flash drives, but still, it knows exactly the order, and they're right in line with each other, right across the line. Clustered index seek means I'm going right to what I need, pulling it back. Clustered index seek is the second fastest thing you can use other than an index seek where it doesn't do a key lookup. So what you you can see the difference between these two. The top one says it took 99%, and the bottom one only took 1%. Obviously, I'm pulling back one zip code. It's a lot faster than pulling them all back, but seeks are always faster than scans. When we're talking about index seeks versus index scans, and it's very similar. The index scan goes through the entire index, has to go through the entire B tree. An index seek goes, I'm going right there, and it finds it. Now in this case, I have an index on state, and I'm only pulling back state. If I needed to pull back something else other than state that's not in the index, what you end up having is a key lookup. In this case, I'm going to the person table where last name equals my last name, but I'm pulling back all the records. So I do an index seek to find my record, but then I have to go back to the clustered index to give me all the other fields. Now in SQL Server 2005, they introduced includes, which is a way you can include extra fields that are not keys on an index that lets you escape this key lookup. The problem is you can only put so many includes before your index starts to get a bit big. And you have to be careful about indexes not only take up space, but they slow down inserts and updates. So you have to be careful with that. In this case, I'm doing a select star, so the key lookup is a little bit more encumbered. But so the last one I'm going to talk about is table scan. You should never see a table scan. There is rarely a reason not to have a clustered index on a table. I've heard a couple of people say, well, I have this table and the primary key is a GUID, so I can't put a clustered index on that, which is true. You don't want to put a clustered index on a GUID, but you should still just put an identity integer field and just clustered index on that. A clustered index makes inserts faster, updates faster, deletes faster, selects faster, because it just does. It orders the data. When you have a table without a clustered index, instead of having something that knows where it's putting it on the disk, it puts it in the heap. Is that what it's called? Yeah, heap. And so it'll just grab disk space wherever it can, instead of being in a nice straight line, and then it'll put little forwarders and tell you, oh, go over here, then go over here. Now, in some cases, if you create the entire table at one time, maybe it is ordered. But if you're doing inserts into this table often, it's going to be scattered all over your disk and not in one nice spot. And again, I guess with flash drives that doesn't matter as much, but you're still not going to get any performance out of a table scan. All you need to do is just put a clustered index on there. Okay, so let's talk about some different joins. Now I have This is, in SQL Server, they define logical operations and physical operations. A lot of the ones down on the bottom, merge join, hash match, nested loops, those can all be used with inner joins, right outer joins, left outer joins, or the anti-semi joins. So, inner joins, most of you guys should know how to do that if you know how to write SQL. It's just joining two tables. You've seen the Venn diagram or something like that. And we'll talk about the different ways that the inner joins work. You can actually see two of them here. One's a hash match and one's a merge join. We'll talk about that in a second. And then your left or right outer joins. Now, I don't know if you guys can see this, but SQL, the optimizer, has actually figured out that the way you wrote this is not efficient. It's actually flipped it around. It starts with the business entity address, and then it does a join over to the person table with a left outer join. It's doing the second part first, as opposed to the first part, because it determined it's going to have fewer records it has to join. So SQL's kind of smart. It tries to figure that out. So merge join. Merge join is probably the best join you can have. If you see lots of merge joins, it's probably good for your performance. Merge joins join two ordered sets of data and just goes, okay, where's this one fit in? Here, 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 and just goes down the line, joining them all. But it only happens if they're ordered. If you don't have an ordered set, it's going to have to sort first before it does a merge join, and that's not always fast. This is what happens. I actually force this to do a sort before doing the merge join. And you can see the one sort operation up there was 44% of this procedure, which is not great. That was significantly bad. And in fact, it even parallelized it. It multi-threaded in order to go faster because it just did not like that plan at all. So the next one is hash match. Hash match is it creates a hash of the first, the one on top, whatever's coming in on the top, creates a hash of that, and then comes in with the bottom one and goes, okay, find find where it is in the hash. Hash match, not bad. It works. It's pretty fast. The last one is kind of the slowest one. This is nested loop. And again, as I said, looping is not something SQL wants to do. And in this case, it loops through the top one and then loops through the inside one to see which one matches. And then it goes to the next one and keeps going. And you can tell that probably takes a really long time. Not the best way to do it, sometimes the only way to do it, though. Anti-semi joins, I just thought I'd put these up here because you'll see them if you look at the query plans. This is usually when you use an exists or where not exists. It doesn't care about getting all of the results back. It just goes, find me the first one. In the case of a not exist, it kind of has to go through a little bit more than a semi-join. These could be merge, inner loop, or hash matched as well. So, okay, and I can show you, I didn't want to hit escape, darn it. The different joins. Now, I don't know if anybody knows you can do this, but I've actually put the word merge in between inner. I said inner merge join, inner loop join. Anyone want to guess which one's going to be the fastest? I can tell you it's not the last one. Okay, the first two have returned already in 2 seconds. Now, I'm probably going to wait the next 2 minutes for the last one to come back. Told you loops were bad. Yeah.
On your joins, is there a difference in performance between using the actual inner join syntax versus the equals or the equal stars down in the where clause?
No. The SQL optimizer, since SQL 2000, will just change it to a join. It understands the where equals. If you just put the commas as opposed to using the inner join syntax. You can't do cool things like this, though, if you did it that way. which is, like I said, it's still running. Oh, did it finish? No. That loop is going to go for a while. I'm doing the same query too. I'm just joining the address and to zip code. So that's fun. How do I start on the slide I was on? Shift F5? I should really learn PowerPoint sometime. Okay, so let's talk about the plans a little bit. Now again, this is terminology that's kind of specific to Microsoft SQL Server. I did look up the MySQL stuff. They've got some similar ones, but let's just go on and talk about these. So one of the things, and this is, I'm showing the actual plan here as opposed to the estimated plan, so I have both things. You can turn that feature on if you're in Management Studio, or if you use SQL Century Plan Explorer, you'll see this. And you can see here the estimated number of rows and the actual number of rows actually don't match. That's not generally good. They're not off by a lot. I've seen the estimated number of rows one time come back at 6.5 billion, which the table didn't even have that many records in it. And the actual number of rows was 1. Trust me, we fixed that statement. That was crazy. It was doing a cross-server join or something, and it just blew its mind. So you kind of want those to go together. You want those to match. What this usually means is that it didn't know. It saw in the index, it thought, hey, there are more rows than that I think are going to be returned than the actual number of rows. Sometimes that's your statistics. SQL keeps a set of statistics on all the indexes, and if your statistics are out of date, then this can happen. Statistics don't, they're supposed to auto-update on their own. They don't. If your DBAs are doing their job, they should be refreshing them every night. I don't know if they are. I did when I was a DBA, but. Estimated I/O cost. This one is especially true if you're going to use a lot of temporary tables or you're using a lot of big data sets. You want to make sure that it's not spooling to disk that often, because a lot of times you'll select this big chunk of data that you're going to join to this other big chunk of data, and in order for SQL to do it correctly, it'll actually drop that to the disk. Even if you didn't say, I want to create a temporary table, or you didn't tell it that, it'll put it in one. In your temp DB by itself. And so you want to pay attention to the I/O costs, because I don't know about you, but we don't all have, our SQL servers are connected to the SAN. Sure, it's fiber channel and all that good stuff, but it doesn't have one of those nice RAID X things that's plugged right in that can get me, the really fast I/O speeds. So you want to pay attention to I/O. CPU cost, I've already talked about CPU cost. You want to keep that down. Again, this can go up in the hundreds. Estimated subtree cost, this is kind of how this statement played within the current execution. If this is a 4 and another one's a 5 in a different connection string, it doesn't mean that this one is necessarily better than the other one. But if you are comparing similar ones, it can help you out. It is something to look at. I've never really figured out the metric that subtree cost is calculated on. Again, estimated number of executions versus number of executions. This actually has to do with when it does a merge, join, or a hash match, or a nested loop, it has to do with the number of times it had to do it. In this case, it's a little odd because it had to do it 4 times, which meant it actually checked it again 4 times. So we'll move down, and that's this actual rebinds down here. Rebinds and rewinds, when it's doing a join, is how many times when it was going down through the data, it started over for whatever reason. Now sometimes that's because the data changed while you were doing the join, so it had to rewind. Other times it just, for whatever reason, saw something and said, I have to start over. So 4 is not a bad number, but it is a number to keep in mind. If this goes up into the hundreds, thousands, then something's going on. I mean, it could just be a table that gets inserted into a lot. So And then when you're looking down at the bottom, looking at the where and the output list, these could be helpful just for figuring out what that particular, if you're looking at this and you see big numbers, you want to know exactly what operation it's doing there. So that's just some information on that. I was talking about MySQL. This is Visual Explain in MySQL Workbench. If anybody's using MySQL, MySQL Workbench is from the same people that bring you MySQL. They put this in. This is Visual Explain. You can also do Explain or Explain Extended, get similar information. But you can see it's actually color-coded, which is kind of nice. SQL Server doesn't color code. There's a free application you can get called Plan Explorer that does color code. But you will see that even MySQL says full table scan. That's that one on the left. It's red. It's bad. See, I told you full table scan's bad. They agree with me. And then it has your key lookups and some of those other things. And it likes to do nested loops more than merges. But again, this is a tool you can use if you're in MySQL to get similar information to optimize your queries. The last thing I want to talk about is results-oriented thinking versus process-oriented thinking. And I got this from, I saw this example most often when people play poker. And it has to do with if I have pocket, this Texas Hold'em, if I have pocket queens, and I'm calling on this, pocket queens, flop comes down, I get nothing, I lose, that guy over there had pocket kings. Does that mean that pocket queens is a bad play because I lost? In poker, no, you stay in with pocket queens, come on. Pocket queens, pocket kings, pocket aces, you stay in with those. However, and they always talk about doing process-oriented thinking. Play the best game you can play. Do the best thing. And in procedural programming, in Java or C#, in a lot of cases, there's somebody code reviewing and saying, no, the best way to do this is this. Or in this way, we do it this way. SQL, because you're not telling it how to do it exactly, you kind of actually have to switch to being results-oriented. Instead of going, I see a problem, you have to go, is it actually a real problem? If you're not seeing a performance issue when you run the code, maybe you might not have to mess with it. Now, you have to make sure you test it at scale. Again, like I said earlier, if you test it against 1,000 records and your production data has 20 million, you need 20 million records to test it against to make sure that the performance is going to be where you think it's going to be. For example, this was something, now this is an interesting statement I ran against. This one I saw first in SQL 2000. And essentially what this does is it does a distance calculator. It does the atangent, cotangent thing for the curvature of the Earth between two latitudes and longitudes. I don't know if anybody's ever written that code. Okay, it's not as fun as it sounds. And there was this function that was doing this. And in fact, this code right here iterates over all of the locations and does that distance calculator rebar, row by agonizing row. Not great. So I looked at this and I was like, oh, okay, I gotta refactor this. This is rebar. So first thing I want to do is I said, well, maybe I'll drop it into a temporary table. Maybe that'll make it better. It didn't really. And then I was like, okay, we're using SQL 2008 now. What if I use a geography data type and I do a distance and the spatial locations and all this kind of stuff? That actually did go faster. But one of the things I found when I was doing the testing is what I really needed to do is I forgot to put an index on zip code on the locations table. That's all I actually needed to fix that. And none of these produced better results. They all ran in like 80 milliseconds. So I was kind of like, okay, it kept running, it kept iterating it, trying to get to something that worked faster. And I wasn't paying much attention to the fact that my results were showing that I wasn't getting any faster. And so I was kind of going down the wrong road. I was trying to fix the code, thinking the code was bad, when it really was an index. So sometimes you have to listen to what the results are telling you. And the other thing is I wanted to show this example here. I wanted to show how bad the performance was for this first one, and then realized I'm running SQL 2014, and they fixed the problem with this. In fact, in SQL 2014, this runs considerably better than it did in SQL 2000. I don't know what they changed, but so I couldn't actually show you. This used to take like 2.5 minutes to run, and in fact, the geography one would run in sub 1 second. So, but in SQL 2014, this one runs in 40 milliseconds, and the other one runs in 80. There's a bit of a difference, and depending on how often you're going to run it, that might matter, but not significant. Because there's actually a bit of spin-up time for doing spatial. It's got to instantiate the SQL CLR. So we talked about all this stuff. What do you want, not how do you get? Talking about how looping is not a SQL concept. Talked about SQL terminology, talked about results-oriented thinking. If you have any questions, that's my contact information. I've got a couple SQL resources up there. SQL Century Plan Explorer is a free application that you can grab. It does. I can actually show it to you in a second. It makes the plan a little bit nicer. Doesn't really give you a lot more information. Kind of breaks it out a little bit more, and fixes the missing index problem they had in SQL 2008. Apex SQL has some nice plugins for Microsoft SQL Management Studio. I really like Apex Refactor. It has something that you can just hit like Control-Alt-Shift-F and it cleans your code. It doesn't make it faster, it just makes it more readable. It's actually really helpful when you grab that output out of your program that constructed the SQL and you take it and you drop it in, it's all in one line. So I just hit that button and suddenly it's all formatted out and I can see all the selects and inner joins. On Twitter, if you're looking for SQL help, if you hit a hashtag SQL help, you'll get an answer in probably a few minutes. There's always people watching that. I can never answer a question on there faster than somebody else can. And you're going to get people that are SQL MVPs or even some of them that pass the SQL Server Masters program. A couple other sites, BrentOzar.com. He's got a couple good scripts that'll go through, I think it's SP Blitz. We'll go through and look at your SQL Server and show you all the crazy things that aren't set correctly in their estimation. And he's also got some great videos. SQLskills.com's Paul Randall and Kim Tripp's consulting company. Paul Randall used to work for Microsoft, wrote parts of SQL Server. Kim Tripp is one of the best best query tuners in the business. So that's a good site. Blog.sqlauthority.com, that's Pinal Davi's site. He always posts like once a week some good SQL snippet. And then mssqltips.com. So, questions? Nobody uses SQL? Go.
What kind of tools do you use for consistent benchmarking to compare whether one query is better than another?
What tools do I use for benchmarking? For load testing? We use Visual Studio Ultimate, the test studio out of Visual Studio. And then we just hammer the heck out of it. And we have a database with, I think it's like 10 million rows in every table. Sometimes not as realistic, but it definitely, it kicked out that trigger. That's actually how we found that trigger problem, is that it ran through a performance test and tanked. So, go. Oh, is the loop still running? That's a good question. No, it finished. 2.5 minutes. Yeah, it's telling me I forgot to turn on the query plan. Oh, well. But yeah, it returned the last loop. It took 2 minutes and 25 seconds. Sometimes I actually just use this as a benchmark, just run the query here and then run it again, but that doesn't give you the load like you were talking about. So that requires a performance environment. Any other questions? I can't start the movie sooner, so that's not a valid question. Go again? Yes. He asked if I ever see different results because of caching. A lot of times, if you run the same query again, you'll see that. There are ways in SQL Server. One of the things that I used to run is DBCC free proc cache, I think it's called. Is that it? There is a one to actually, I'm trying to remember it off the top of my head. Okay, drop clean buffers. Free proc cache also does it, I think. We'll actually clean the proc cache, or you can, would you say drop clean buffers? Yeah. So then you can always be clean and not worry about cache, because that's, you really want to do it that way when you're doing the testing. You don't want to have a cache results and think, I made it better, when in fact you just ran it twice. Way in the back.
What's your opinion about using views?
My opinion on using views? Views are fine, provided the view actually does something. The application I currently work on has views that they just used to rename the tables with. Literally, the view is a select star. In lieu of making joins. I mean, that's part of the reason that you have a view is to make it easier to do the data. Now, you want to make sure that the underlying tables still have the indexes you're going to use through the view. There is a way to make an indexed view as well in Microsoft SQL Server, though that's not always as easy as just making sure there are indexes on the underlying table. I mean, I don't mind doing that. It just puts another layer in between getting to where you need to optimize, but it's fine. Nothing else? You all want the popcorn? Okay, go. Hibernate? I haven't used it, so I don't know. Yeah. Some of the stuff does apply to Oracle. I mean, you've still got the same problems with, I don't think that, I'm trying to remember if they call them cursors or not. I don't think so. They still have loops and things like that that can be refactored out. I haven't worked with our Oracle guys that much where I work, but, because to be honest, they're shifting to SQL Server to save money, so. Yes? Have I ever run into the situation where SQL Server can't get a good plan? Because it times out before it even creates the plan. That sounds like a really complicated statement you've written. I've seen ones where the plans are huge. And in that case, I'm not exactly sure how to refactor that out. Possibly breaking up the store procedure if possible. Sometimes maybe you do have to get it in smaller chunks. There's also the possibility, I saw this where we were getting a bunch of deadlocks on our data warehouse, and it was because and what we did is we moved the clustered index from one date to another, and that solved all the problems because it was querying that more often than anything else. So sometimes you might want to look at the index usage, which indexes are actually being used. And I've seen times where there's an index seek that's always happening on this one field, and it's always doing a key lookup after it does that index. And the clustered index has no seeks on it. And that means you probably have the wrong clustered index. Okay. I think I'm at time. So. Do I have 15 minutes? Okay. I went really fast, didn't I?